Hello, my name is Greg Johnson and I'm a science consultant at Wayne Risa. I'm going to be sharing with you one way that we can implement the engineering components of the Michigan Science Standards in elementary and middle school classrooms. Of course, our standards now include engineering design from kindergarten to the 12th grade. Interestingly, research done with young students suggests that many students don't really understand what engineers do. They often think that engineers are the people who build roads or build bridges or build houses, and not that engineers design all these technologies in every aspect of our daily lives. I'm going to showcase one option that many teachers find useful. Engineering is Elementary is a powerful way to incorporate engineering into our elementary and middle school classrooms. The curriculum highlights the design process that many engineers use. Additionally, the curriculum guides students in the exploration of a huge variety of engineering specialties. This curriculum also contains some research-based components that support a number of important engineering targets. Let's take a look at a couple of these engineering targets. Let's start with middle school. One of these engineering targets is to identify a problem that needs to be solved. At Shoemate Middle School in Gibraltar, Jeff Bowman has his students designing a solution to a particular problem. His students are presented with different animals that need a prosthetic device. The students are told the story of an elephant in Cambodia that had lost part of her leg in a hunter's trap. His students have to act like biomedical engineers and create an artificial limb or prosthetic leg that allows the elephant to move. His students have to identify the criteria for an acceptable solution and constraints to this biomedical engineering problem. The students work as engineers to design a technology. A technology is anything that is created by people that helps solve a problem or meet a need. The students will act like engineers and design a prosthetic limb for the elephant using themselves as the model for the elephant. The prosthetic leg has to meet these criteria on the slide, such as supporting the student's weight and being comfortable. It also can't fall off during the testing phase when all the students have to model how their device works. Additionally, the students have to create with the limitations of time and materials. This process of continuous improvement, or the iterative process, is hugely important. It's the process of creatively thinking about a solution that leads to a prototype that is then tested, evaluated, and then improved. The students collect data during the evaluation process, and that data guides their improvement efforts. This is the actual I can statement that Jeff had written on the board for his class. It says, I can improve my prosthetic leg design. This is huge. This whole improvement process is very, very important in the engineering design process. This gets at the heart of the engineering design cycle. It's the iterative process where students test their design based on their criteria and then work to improve their design. In this interview, you'll see students reflecting on their process of creating a prototype and then modifying that prototype based on data that they've collected.
This was an old project, old prosthetic leg, and we're going to make it a little bit better, a little bit taller than this and stable enough, because this was not as stable and it kept making sounds. And we're going to make it kind of like this. We're going to make the wall stable enough so it won't break when he's walking around the room.
Yeah, but with this one, it felt unstable because once I put my leg on here, it started to crush down and I couldn't even do it. But with this new model, we have the foot, which will actually act like a real foot. When it goes down, it should act like it because of the way we have it. We have a slot that my leg can go fit into, and then we're going to tie it really tight with rubber bands and strings.
What might this look like at the elementary level? Crystal Brown at Weiss Elementary in Gibraltar has her students using the Engineering is Elementary curriculum to design solar ovens. This is the prototype of a solar oven that was built after the students had collected data of what materials make the best insulators. Science and data collection is incorporated into the unit as the students explore what materials make good insulators and which of these materials is more natural and requires the least amount of processing. The students also need to calculate the cost of producing their solar ovens. They could design a great solar oven, but if the costs are too high, their prototype could never go to full-scale production. One of the cool things that EIE incorporates into their curriculum is time for independent thinking. Each member of a design group must create their own design independently before they come to the group. This ensures that those students who are less vocal get a chance to share their design components so everyone participates. It also ensures that those students who like to take control are forced to compare each other's design components and evaluate the pros and cons. As in the middle school units, the elementary students have to evaluate their design and then refine or improve their design based on the criteria and constraints. In conclusion, Engineering is Elementary supports these 3 engineering targets: thinking and behaving like engineers. All the students go through the same thought dispositions and behaviors as engineers in the field. Number 2, creating technology based on criteria and constraints. All the students are involved in creating a technology. They have to see the target that would show that they are successful, that's their criteria, and then be aware of the constraints, their limitations, such as time or materials. And the last one, that the students will engage in the iterative process, the process of continuous improvement. The students develop a design, they create the prototype, they test that prototype out, they evaluate it. Did it meet the criteria? And what ways could I improve it? Then the students go through this improvement process where they change their design a little bit and they evaluate it again.